Hi students, this is your Shiva and you are watching Shiva's Maths Library. In this video, we are going to learn in detail about the linear polynomial. In our previous session, we saw what are the meaning of the definition, term and coefficient and also variable, constant, everything. And finally, we learned about the degree of a polynomials. Here, before starting about the linear polynomial topic, we need to recall that polynomial whose degree is 1 is called a linear polynomial. See here they have clearly mentioned that this is the meaning of a linear polynomial. So a polynomial whose degree is 1 will be termed as a linear polynomial here. Here we'll start with the example number 4 where the perimeter of a square of side x is 4x, which is a linear polynomial in a variable x. Correct, because here we can able to see that the perimeter of a square is given as 4x, so we can consider this as a polynomial. Here we are having only one variable x and whose degree is 1, so we can say that this is a linear polynomial in the variable x. Here find the perimeter of a square with side 1 centimeter, 1.5, 2, 2.5 and 3. What will happen to the perimeter if the sides are increased by 0.5? See here we know the formula for perimeter of a square, which is given as 4x, and here the side length are given as 1, 1.5, 2, 2.5 and 3. So finally what we need to do is we have to show that what will happen when they increase the side by 0.5 centimeter. So let's do this. Here we know that perimeter of a square is given as 4x, and they have given different values of x. One is 1 centimeter, 0.5, 2, 2.5 and 3. Let's find the perimeter value. If I substitute x is equal to 1 here, I'll get 4. If I substitute 1.5, 4 into 1.5 it will be 6, 2 into 4 it will be 8, 2.5 into 4 it will be 10 and 3 into 4 it will be 12. So when you compare the values of x and corresponding perimeter values, here for 1 I am getting 4, for 1.5 6, 2 8, 2.5 10 and 3 it's 12. So if I increase the x value, if x increased by 0.5 centimeter, perimeter is perimeter increased by 2 centimeter each cases. See, 2 is 4 plus 2 6, 6 plus 2 8, 8 plus 2 10, 10 plus 2 12. So this is the final result that they are asking. So here it is clear. So the question is what will happen to the perimeter if the sides are increased by 2 centimeter, and the answer is perimeter is increased by 2 meter. Perimeter is increased by 2 centimeter. So this is our answer for this particular problem. Okay, and in the next one, in example number 5, what they are asking is a chess club charges a joining fees of rupees 200 plus 50 for every match is played. The following table shows the amount a player will have to pay as the number of matches varies. See here, the chess club charges a joining fees of rupees 200, which means at the time of joining, it's like a admission fees. You are paying rupees 200 rupees plus rupees 50 for every matches played. So whether you are playing a match or not, you have to pay rupees 200. So 200 is a basic charge which is fixed. So this will be considered as a fixed charge. So there is no change. In our definition of an algebraic expression, the value or the term which is always fixed is termed as constant, right? So here we can say that this is constant which is never going to change. So this 200 is going to be a constant value. Now for each match they are going to play, they have to pay rupees 50. So for one match they are paying 50 rupees plus joining fees of 200, so they are paying 250 rupees. If they play two matches, for two matches it is 2 into 50, 100 rupees. So 200 plus 100 it is going to be 300. So here we can split this 200 250 the entire amount in terms of joining fee plus the number of matches they played. So here I am writing this 250 as this is 200 plus 50 into 1 because he played one match. Okay, so similarly this 300 can be termed as 200 plus 50 into 2. Okay, because they played two matches, so 2 into 50, 100, 100 plus 200, it is 300. Similarly, for this 350, you can write 200 plus 50 into 3. So 350s are 150, 150 plus 200, it is 350. Like that, for 400, it is 200 plus 50 into 4, as they played 4 matches. So for 4 into 50, it is 200, 200 plus 200, it becomes 400. So this is how the total amounts are determined. So we can able to see the clear pattern here. Actually, see, 200 is fixed for all the cases, 200, because it's a joining fees, and 50 is also a mandatory fees because they are charging rupees 50 for each match. So this is not going to vary. Which is getting varied is the number of matches they are playing. Here they played one matches, here they played two, here they played three, here they played four. So for each matches we are going to multiple the number of match with 50, and we will add with the joining fees of 200. This is how we can able to find the total amount that the particular student has to be paid. So here for M matches, as we know that if it is 4 matches, 50 into 4 plus 200. For 5 matches, it is 50 into 5 plus 200. For M matches, 50 into M plus 200. So this is the pattern. Okay. So based on this, what we are supposed to find in this particular problem is, if a player paid rupees 750, how many matches did he play? So this is an important question. See here, they've given up to 450. If he played 5 matches, yes, he's supposed to pay rupees 450 rupees. So for 6 matches, 7 matches, 8 matches, we can able to find, but they have not yet given. We have to find the number of matches that they have played based on this amount of 750. So let's consider this as a linear problem. Okay, basically the number of matches played can be assumed as x, where 1, 2, 3, 4 and m are given, and amount to be paid will be assumed as a. Okay, so this is nothing but 250, 300, 350, 400, and finally for m matches it is, we found the pattern, it's 200 plus 50m. Okay, so based on these two things we can able to, as we know that perimeter is, how we have expressed the perimeter as a function of x, right? So similarly here we can apply amount is equals to as a function of x. Amount as 200 is a basic fee plus 50 is the fee for each match, and the number of minutes that they are going to play is x. So area is given in terms of x as 200 plus 50x. Whenever we are substituting the value of x as 1, 2, 3 and 4, we'll get the value of the amount they need to pay. Here in this particular problem, amount is given. Amount is given as rupees 750. We need to find what is our x, how many matches did he play. So I'm going to replace the 750 here. So 750 is equals to 200 plus 50x, and we'll bring this 200 here. So 750 minus 200, it will be 550, which is equals to 50x. And to find the value of x, we'll bring this 50 to the denominator. So 550 divided by 50 equal to x, where 0 0 and these two may get cancelled, which is 11 times. So this implies that x is equals to 11, which means if he is paying rupees 750 means he played 11 matches. Okay, how many matches he played? 11 matches. Okay, so this is our answer. The question is, how many matches did he play? He played 11 matches. Okay, so here what they are trying to give is, the example given above highlights the characteristic features of a linear polynomial. So this is the linear polynomial, actually the one which we took, no? So this is a linear polynomial because the degree is 1 and the variable is x. See, this is our variable whose degree is 1. Okay, so characterize the features of a linear polynomial, that the difference between a consecutive values at an integer is a constant. So this is what given. Okay, successive values at integer is constant. In example 4 also we saw the same thing, similar to example 5. Okay, so here the amount paid by the player is increased by 50 for each every additional matches played. Such patterns are called as linear pattern. That is how it is getting increased, right? We can able to find the values by using a linear polynomial. So the pattern that follows by the linear polynomial is called a linear pattern. And also when we equate the linear polynomial in one variable to a constant, especially 0, we'll get a equation. Such equations are called as linear equation. Like in the previous case, we found the amount is given by 200 plus 50x, right? Suppose if you are equating this to 0, like 200 plus 50x is equal to 0, this is linear polynomial. This linear polynomial, when we are equating is equal to 0, we can say it as linear equation. So this is called a linear equation in this case. Okay, so we have a last example, example number 6. The sum of two numbers is 64. One of the number is 10 more than the other. So what are the two numbers here? So here they have use some method, but I'm going to use a different method to find the solution of this particular example. Here the clues are, the sum of the two number is 64. Okay, basically here they didn't give what are the two number. Okay, so what we are going to do is, let us assume that let x and y be the two numbers, because we don't know the number, so we have taken our variable x and y. Okay, so whose sum is 64. So this is clear that if I add x and y, I'll get 64. Okay, see, sum of the two numbers is 64. One of the number is 10 more than the other. Okay, and here we don't know which number is 10 more than the other. Either x can be 10 more than y, or y can be 10 more than x. That we don't know. We can take that x is equals to 10 plus y, or y is equals to, 10 plus x. Okay, you can take anything from this example. Okay, but this is clear, sum of the two numbers should be 64, and one number is 10 greater than the 10 more than the other. Either you can take this or this, it's your wish. So I'm going to take the first case of x is equal to 10 plus y. Now I'm going to substitute this value of x as 10 plus y in equation number 1. So equation number 1 can be termed as, if I replace this x as 10 plus y, then 10 plus y again plus y equal to 64. So it is 10 plus y, it is 2y equal to 64. This implies 2y is equal to 64 minus 10, it will be 54, and y is equal to 54 divided by 2, it is 27. So we got the value of y as 27, and if you substitute the value of y here, so x is equal to 10 plus 27, which is equal to 37. So the two numbers are nothing but, therefore two numbers are 37 and 27. Two numbers are 27 and 37. That's all. See here they have used a single variable method. Okay, smaller number, let the smaller number be x, and the larger number must be 10 plus x, because one number is greater than the other number, right? So smaller number is x and the larger number is 10 plus x, and their sum is 64, which means they have to add these two numbers x and 10x. So if they add x and 10 plus x, which will give the answer as 64, and x plus x is 2x, so 2x plus 10 equal to 64. And one more thing is 2x plus 10 equal to 64. Here we know one important thing, when we are equating a linear polynomial in one variable to a constant, the equation is called a linear equation. See, this is a linear polynomial, we are equating is equal to constant, so it's a linear polynomial. So note that this is a linear polynomial which is equating to 64, a constant, so this is a linear equation. So we can solve the linear equation, and we finally found the numbers as 27 and 37. This is how we found the answer by using our old method, by considering two variable x and y. Okay, either you can use this method or the one which we solved, both are correct. Okay, so polynomial can be thought as an input output process. Okay, this is an important statement. Polynomial can also be thought as an input output process, because see, whenever we are taking a polynomial, okay, so here yes, we can take this as a polynomial, this one as a polynomial, or this one. Okay, so like f of x, because the variable is x, f of x, which is equals to 2x minus 54. Okay, so whatever the value of x you are giving, you will get corresponding output value. Suppose if you are giving x value as 1, 2 ones are 2, 2 minus 54, it is minus 52. If you are giving x as 10, 2 tens are 20, 20 minus 54, it is minus 34. So for instance, consider the polynomial 2x plus 3 for x. There is a corresponding value of polynomial 2x plus 3. Suppose if you substitute x is equal to 4, 2 into 4 it is 8, 8 plus 3 it will be 11. So if for x is equal to minus 6, you will get 2 into minus 6 it is minus 12, minus 12 plus 3 it is minus 9. So for each x value, which means you are giving an input value, you are getting some corresponding output value for each input value. So that's why they are saying that it's like an input output process. Such process are termed as function, so which we will learn at your higher classes like 10th, 11th and 12th standard. Okay, so this is kind of machine, input output machine. So whatever the input value you are giving to that machine, it will make some output, and you will get the output value as y is equal to 11 when we are giving the input value as 4. Similarly, you can give any number, you will get corresponding output value. Okay, so based on this, we can learn that how to evaluate the value of an algebraic expression. We substitute the value of variable in a given expression. Consider example 3, that is from our first exercise, where the wire is bent to form a rectangle. Here the area of the rectangle is given as 10x minus x square. So we can say that area is a area is a polynomial which is 10x minus x square. This is not a linear polynomial. You know that for a linear polynomial, maximum degree should be 1. Here the degree is 2, so it's not a linear polynomial, it's a quadratic polynomial. It's a quadratic polynomial. Okay, so what we need to do here is, can you interpret this as an input output process? Yes, we can able to interpret by considering this area as a function of a of x. A of x is equal to 10x minus x square. So for each value of x, you will get different output. Suppose if I substitute x is equal to 1, 10 ones are 10, minus 1 square is 1, so the area value is 9. So for what value does the expression when x is equal to 6? Similarly, they are asking for x is equal to 6. So substitute here. So a of 6 is equals to 10 into 6, it is 60, minus 6 square, it is 36. So 36 and 60 subtraction will be, it is 24. So area will be 24. So we can apply the input output method for this problem also. Okay, then note that 2x plus 3 is a linear function, where yeah, this is what we have written already, right? The one which they have given in the input output machine is a linear polynomial, but the one we took is a quadratic polynomial. Okay,